Hello, my name is Sean Ditchko and welcome to this third video in the series on using spreadsheets. What you see now is the first video where you learned how to enter formulas into the different cells, and also you learned how to make a basic graph. In video 2, we added another column to the same spreadsheet which has data with random error introduced that simulate real-world measurements. In this video, video 3, we're going to add this fourth column, velocity from a best fit line. We're going to simulate what you do with paper and a ruler, and we're going to take the data in this graph and create the best fit green line. But we're going to do it just visually, so we really are simulating using a ruler on paper. Let's start by graphing the data. We'll click on this chart icon, choose the XY scatter, then we'll select the data range and choose A1. Holding the mouse button down, we'll drag over to C32. Remove this checkbox. The first column is not a label. In fact, it's part of our data. The data series, select that. We'll remove the theoretical data because all we want to plot right now is the velocity with the random error introduced. Everything looks good. We have the X values is from the A column, that's our time, and then the C column contains the velocity with random error, so that's good. Click on the chart elements and we'll remove the legend and create a title and label the axes, and that should do it. And there we go. Let's move this around a bit. Now we're going to make a visual best fit line for this graph. Let's copy and paste this into another program so I can show you what I mean. A visual best fit line, it's real simple. You look at these data points and you say, that kind of looks like a straight line. That's how you know what function to use. There we go. There's our best fit line visually done. And now I could be a little more careful about it, but in fact a whole lot of calculation has actually gone into that careless looking line, and because your visual system actually does lots of approximation. But let's be a little bit more careful about it. Let's try one of these straight line things here. That's pretty good right there. That's a better visual best fit line. Now there's some decisions to be made here. Mainly, what is the intercept with the y-axis? That's b in this equation, also known as the y-intercept. And the second decision is, what is the slope of this line? Should I instead have made it look like this? Is that a better best fit line? I mean, no, and I think the reason it's not is because it's above most of the points here. Now, these letters M and B, the slope and the y-intercept, these are the parameters of our fit. And in video 4, we'll make a sophisticated, using a chi-squared analysis, we'll optimize for these parameters and figure out exactly what those numbers should be. But for now, we're just going to do a visual best fit and kind of guess. We'll go back to our spreadsheet. We're going to create a line using this equation y equals mx plus b, and we'll create one cell with the slope m and another cell with the y-intercept b, and we'll tweak those cells just by hand until it makes a line which we think is close enough to the best fit line. So we'll copy over the column heading that we're going to be making now, this best fit line, and we're going to create an equation here, and we're going to say it's y equals mx plus b. But first, we'll need to put the parameters slope and y-intercept into some other cells in the spreadsheet. So let's do that now. And the two parameters will be slope and y-intercept. But those parameters have a physical interpretation, as all parameters in a best fit do. And in this case, the slope, the velocity over time, the slope is the rise divided by the run. The rise on a graph like this would be the change in velocity, and the change in velocity divided by time is acceleration. In this case, it's the acceleration due to gravity because we're simulating a free-falling object. Let's copy this over, and the estimated initial velocity, which we're just going to say it's probably 0, but let's copy that over. Let's take a guess about what the acceleration due to gravity is. Maybe it's something like 4.5 meters per second squared. I don't know. Let's take a guess. The initial velocity, maybe it's positive 2. Well, now we can go and make the equation for our best fit line and use these numbers as our parameters for it and see how close we get to the data. So we'll go equals, we're typing in the formula now. We have initial velocity, which is cell J4, using dollar signs to make these absolute cell references so that they don't change as we copy the formula down the column, plus J3, which is the acceleration, times the time, which is A2. And the A2 did not get dollar signs in front of it because we want that to change as we copy the cell. So here is our data for a best fit line. Now we need to get that onto the graph now. So let's double click the graph, then right click and you'll see the data ranges option. Select that. And we're going to add a new set of data. We're going to give it a name. Let's call it the velocity from best fit line. The X values will be the time, so we'll click on this select data range button for the X values and include the word time there, include that label. There we go. And then the Y values will be from this column. Okay, now that doesn't really look super. We want this to be a best fit line for one thing, and so let's make it a line. We'll change the formatting of it and get rid of those red diamonds. We want to have a continuous line style. We don't want any icons, so this will remove those diamonds. And we're getting a preview right here of what this is going to look like. And let's make it green. Click OK. Good. So now we have our best fit line. Well, it doesn't really fit very well at all. So at this point, we're going to do some visual fitting. Let's change these numbers so that the green line seems to make a best fit through all the red diamonds. Looks like it needs to be a bit steeper. Let's try 6. Yep, that's a little better. Let's try 7. Getting even better. And so really the process is just like this. You play around with numbers until you get something that works. This is visual best fitting. A little bit steeper still. Let's try, I don't know, 9.8 maybe. Ooh, that's a random sounding number, isn't it? There we go. 9.8 looks pretty good. Yeah, I'd say that's a great best fit line right there. We know that the initial velocity is probably 0. I mean, at least that's how we set up our simulation. But, to be honest, if you didn't know that, this looks like a great best fit line as is. Another thing that should really be on this graph, which is also helpful for creating a best fit line, is some error bars. So let's double click the graph again, choose this data series and right click on it and insert Y error bars. And we're going to have a constant value of 5. And there we go. I chose 5 because that's our standard deviation. Now when we look at this best fit line, it should go through the error bars 68% of the time. 1/3 of the data, just on average as a rule of thumb, is actually going to be outside of the error bars. There we go. We can zoom in to have a closer look. Looks like it's going through the error bars most of the time, except maybe not on this one. And then maybe not on this one. Maybe not that one. But generally it's pretty good. It goes through about 2/3 of them. So this is the process of making a best fit line visually using a spreadsheet.